Hi, in this video we're going to look at a conjecture, a statement, and see whether it's always true for all values, or never true, or sometimes true. Now let's look at this conjecture, this statement. Siena's proposed that a minus b is always greater or equal to c given these constraints here. So a has to be greater than 6, but not including 6. B has to be less than -3, but not including -3. And C is got to be between 4 and 10, but not including 4 and 10 themselves. And A, B, and C are integers. Remember that integer just means whole number, right? Right, now, we got to see whether this conjecture is always true, sometimes true, or never true. Now, let's try some different examples and just get a kind of feeling about what's going on here. Let's say a is equal to 7, because we said that a is greater than 6. Now, b's got to be less than -3, so let's just say b was -4, because -4 is less than -3. And c is some value between 4 and 10, let's just say, I don't know, 5. And now, the statement that Siena made is that a minus b is greater or equal to c. So let's try with our numbers. If we do a minus b, so a minus b, so it's 7 minus -4, which is 7 plus 4. Is it greater or equal to c? So we can see that is just 11, which is greater than 5. Now, this is true. So therefore, we know that the statement might be true, or it might always be true, but we know that it's not never true because we found an example where the statement is true, right? But it could still be one of these two here. Now, how do we know if it's sometimes true or always true? Well, if we think about it, there is limited values that C could be. C could only be 5, 6, 7, 8, or 9. But let's kind of look directly at the statement. If we want a minus b to not be greater or equal to c, so we want to find an example that doesn't work, we certainly don't want to pick a big value of a, like a can be any value greater than 6, right? So if I made a like 1,000,000, for example, then 1,000,000 minus some number is going to be bigger than c, yeah? Because c is limited between 4 and 10. So we want to pick as small a value of a as possible, which we did. Look, a was 7. 7 is the smallest value that's greater than 6. Also, if we want to make this left-hand side as small as possible to get something which is not greater or equal to c, so to make the smallest possible, I want to subtract a big number. So I want to make b as big as possible. But we did do that. We found the biggest value of b, which was -4 here. And so we actually did the smallest possible value of a minus the biggest possible value of b. So when we did 7 minus -4, that was 11. And basically, that is the smallest value of a minus b that we could actually get. Now, if this is, we know this is going to be at least 11. Is 11 always going to be greater or equal to c? Well, c can only be between 5 and 9, right? Inclusive. So it's always guaranteed that a minus b is going to be greater or equal to c. So the answer here is it's always true.